Lecture 4 Climate Part 1. The climate is one component of the flow water flow part or component of the hydrologic cycle. The climate is a component that the water stay in the atmosphere in terms of the vapor pressure or vapor before it turn to the liquid, to the precipitation. That the driving force to make the rotation of water in the air come from the solar radiation. Sorry. Energy emission from the sun or any object follow we call the Stefan-Boltzmann equation. So this equation is radiation is a function of the temperature power 4 and it depends on the coefficient of emission, emissivity, and sigma Stefan-Boltzmann constant. Okay. In this case, the temperature is in the term of the degree Kelvin, and you can expect that how much of radiation, because of temperature of the sun is about 5,700 degree Kelvin. And for the next is for the wavelength. Wavelength is x is a function, is an inverse proportion with the temperature. So it means the high temperature give the short wave. So in term for the sun, provide the short wave radiation, and from radiation from Earth, because of the low temperature, is provided long wave radiation. The next topic is about the atmospheric circulation. The movement of the air is depend on different temperature. You can see at the movement of temperature is moving up from the equator because of the hot air from receiving energy from the sun. So make the hot air moving up, and the cold air from the equator, from North Pole, moving down. So it makes the circulation of the air, and this is come back to the pole. Okay, and similar from the South Pole. Okay, in this case, for Earth is no rotation. In this case, it's no rotation. For the next case, if the Earth is a rotation, and smooth surface, you can see that the direction of the wind is inclined direction from northeast. Okay, so we can explain why the direction of the wind is northeast using the angular momentum. Okay, we can the angular momentum is mean omega is equal. It means the mass times R1 V1 is equal to mass times okay, this is concept of the angular momentum is constant. Okay. This radius of rotation, the top one is close to the polar, but the bottom one is close to the equator. So the radius at equator is greater than R2 is greater than R1, and because of the Earth is moving from the left to right or from west to east, so we expect that it brings the mass of the air moving with the Earth. At the same time, it's moving along from the north to equator, from north pole to equator with the velocity u. Because in this case we say that the R2 is greater than R1, so based on the conservation of angular momentum, mass is the same mass, so it means V2 is less than V1. So in this case we can, so it means we can write the vector of velocity u, because of V2 is less than V1, so the difference of velocity is delta V. Sorry. So the relative velocity is this direction. So that is why the direction of the wind when moving from the high latitude to the equator is in this direction. Okay. Similar to this direction. Okay. Okay, this figure just show the tropical cell, neutral cell, and polar cell. Okay, the three circular. This part is the polar cell, middle cell, and tropical cell. The rotation of the wind between the equator and the pole. This figure shows the real condition for the wind direction on Earth. So this is with the condition with the rotation. So in the real condition is the surface. The Earth surface is not smooth; it's a rough surface. So we expect that there is the high pressure, area of high pressure, and there is a jet, subtropical jet or polar jet in this area on Earth, and there's a front between the cold and warm air. And this figure shows the general global circulation on Earth. Okay, in terms of the surface surface wind and up down draft and jet stream. Okay. This figure shows the the front between the cold air and warm air. When the cold and warm air come together, and when the warm air push the cold air, we call the warm front. Another way, because of the warm air it's lighter than cold air, is moving up. At the same time, cold air is heavier than the warm air. Is pushed the warm air, we call the cold front. Okay. This figure shows the climate system, and we have the many parts in the climate system. We call the start from biosphere, hydrosphere, atmosphere, okay, and cryosphere. And we may heard often about the climate change. So what is climate change, and what is the impact of the climate change? This block diagram is show the interaction between Earth system and human system. For Earth system is climate change. So what is climate change? Climate change can be the temperature change, precipitation change, sea level change, and extreme event. And this come from the driving force is from the climate process driver, and the impact is create impact and vulnerability. Okay. And both the process and impact it come from the socio-economic development from the human system. So for the human, we can do two things to do mitigation and adaptation to survive in the climate change. This part shows the one example of climate change is from we call the greenhouse effects. This from the left hand side is for from the natural greenhouse effects. The radiation, solar radiation can come in and can be go out. Okay. And after we have the high thickness of the greenhouse gas, the solar radiation is come in, but it can't go out. It increase the what we call the re-emitted heat inside the Earth's atmosphere, so it's caused the high temperature. So that is we call the greenhouse effect.